Okay, we've got to find the nature and the force in member A. Again, they're going to call it member A. They have given us, oh, they haven't given us supports. Okay, that's a bit of that's, oh, you know what, we can do this without finding supports. Okay, so this is a cantilever beam, right? Like I mentioned a surfboard earlier. If I put a surfboard between two bricks and I stood on the edges, I could have, so I'm just going to draw that diagram like this. So I have two bricks and I have a person A standing on the surfboard and person B standing on the surfboard. We can see how they're holding together. Yeah? So in that case, I'm going to assume that the bricks, these supports are going to be pushing up, but I don't know. It isn't necessarily the case. If this person's really fat, that brick might need to be tied down. Okay, so what we're going to do is we are supposed to find support 1 and support 2. Well, actually, just asked us to find support 1. I'm not going to do that because I don't need to. Right? With trusses, sometimes you can just get away with just not finding the reactions. Because what I'm going to do is I'm going to get my minion saw and I'm going to cut through that section there. Because I want to find member A here, down the bottom, is what I want to find. And I'm going to redraw that diagram here. So I'm going to say my diagram is going to look like this. Better arrow than that. 450, and that's in newtons. And I have, they want us to find A. No, they don't. This is A down the bottom. And I like to call these ones P and Q. Now, how do I get rid of P and Q? Which method am I going to use? Meet up or lone wolf? Does A do something different? Do P and Q meet up?
P and Q meet up.
P and Q meet up. So we're going to call that point X. So the only thing is we need to know some distances. So they've said this is 10 meters, and we can assume, because it doesn't say that the drawing's not to scale, we can just assume that the drawing is to scale. Right? So if there's 10 triangles, how big is each triangle? 5 triangles, and they're each, it's 10 meters. How big is 2? Okay, so each is 2 meters, right? So the only thing we're going to need to do is we're going to need to know what is.
Doesn't it say that up in the text?
It does. All members are 2 meters in length. Good work. Good reading. Most important power. Could you imagine like Cyclops and Wolverine, and they're like, but she can read really fast. Anyway, it's still a pretty good superpower. Okay, so if that's the case, how big is this distance going to be? We've said before, if this is 2, we cut it in half, we get 1. That'll be square root of 4 minus 1, so 2 squared minus 1 squared is going to be square root of 3. We know that square root of 3 is 1.73. 1.73. Right? But if you wanted a more accurate answer, you could use that value of root 3 in your calculations. Right? By all means. Okay, so let's go. We're going to say sum of the moments measured from point X equals 0. 0 equals, now I talked about how we don't need to write P times 0 and Q times 0, but I do. And then I've got 450. And before I write my distance, I like to think, okay, I'm putting my finger on the center of my circle, X, my axis, and go anti-clockwise, so it stays negative. How far away is it from X? It is a full triangle, so it's 2 meters away. Yeah. Okay, and then A is, well, we're going to say minus A, and then we're going to say, is that anti-clockwise, yeah? Yeah, you happy? Anti-clockwise? Now again, we can see if we've got 2 anti-clockwise, you should be worried. Yeah? Okay, so what are we going to have out as our answer? 0 equals, 2 times that is minus 900, equals minus 1.73a. So I bring that over here, I now get 1.73a equals minus 900. Oh, I didn't write up here, you don't need to write this, but I do. You can write Okay, so assume tension, therefore it's anti-clockwise. But it turns out that the answer is negative, therefore their assumption was no good, therefore it was in fact compression. Yeah? And so we can say, well, if I could buy 1.73, let's say if I could buy 1.5 apples, really, really expensive apples for $900, right? How much do you think one apple costs? About 500 bucks. Yeah? Okay, so the answer is 520. I like to do that because I like to think in terms of when estimating. A lot of people say that if you use dollars, it really helps you you kind of feel as though it tricks your brain into thinking there's more on the line. And it's in kilonewtons, yes, no, it's just in newtons, and compression. Okay, so that was 3 marks. In the exam we'd have 5 minutes to do that. I maybe took longer or shorter, I don't know, the people watching on YouTube will be able to see, but that's how long it took. Can you, one more down, 3 to go. Can you give me the next question, please?
Okay.
Probably should be taking photos of these. No, just click to the next tab. Okay, good. Okay, so the next question is the 2005 paper, question 12b. I'm going to zoom in just a little bit, so you didn't really see me any time anyway. That's probably as close as I want to. Oh, one more. Yeah, okay, fine. Okay. So, again, they want us to find the force in member AB. I feel as I did this one recently in class, but having a video of it could still be good. All of these videos that I've done today, every single one of them I have set for homework for my class in 2020. So that's how I chose them. This is why there might be some skips, but it'll do for today. Okay, so the first thing I want to do, this is a bit more of an interesting one. The distances, I think, are what are the problem here. Now, we'll talk about there's 2 different strategies for approaching this. Yeah, okay. Just wondering if I have done this one on video. It doesn't matter. If it does, it does. Okay, so the first thing we want to do is we want to cut our section. Yeah? So we're going to cut our section, and we can say, well, we can take the left-hand side or the right-hand side, but if we take this side, I have to solve it. I have to find those unknowns. You have to find those reactions. I don't want to find B and C. That's difficult. That's a pain. But if I take the left-hand side, there's no unknowns. So that's convenient. Yeah. So what I'm going to do is I'm just going to draw that diagram again, but I am going to draw it. Now, the thing is, you might ask about, what about this one? Why do I ignore this one? I don't care about anything that doesn't get cut. I only care about external forces, like this 10 kilonewtons. I only care about this 10 kilonewtons, or members that have been cut. So I'm going to call these here AB, this one here P, and this one Q. That's it, that's all I'm going to find. Now, the question is here, if I want to find AB, then what method do I use to get rid of P and Q? Meet up. Okay, well, where do they meet? Yeah, at C, at point C, yeah? Okay, so the difficult thing here is that we now have to find, I'm just extending that along, right? What we need to find is we need to take our set square, right, and draw a right angle triangle, right? Yeah? I think it looks pretty close to a ring right angle, maybe a little bit off, pretty close. Close enough. Okay, so I need to find the distance of that blue line. That's what I need to do. To find the distance of that blue line, well, okay, the first thing you can do is you can see that these drawings, we can always assume they're drawn to scale. Now, the 2019 HSC, for some reason, said not to scale on the paper. It's the only year that I can recall where they've said not to scale, and I am very, very, very confident that the HSC markers would have still given students full marks even if they had drawn something to scale. So what I can do is I'm just simply allowed to say, if that's 1 meter, then I'm just going to draw this one here to scale. You can just draw it like that and just draw it to scale. I drew that with my left hand, that was not ideal. Right? Now I can look at that and I can say, well, it's probably about 400. Yeah? Now, you would actually use a ruler and do a calculation to figure out the scale. But my guess is that I'm going to call this distance here, I'm going to call that D. Right? That is, in fact, a D, right? Yeah, drawings. Okay, and my D, I don't know, but I'm going to guess it's about 400. Okay, so the question is, I'm not generally very interested in doing the trigonometry components of these questions, right? Because for me, I'm like, if trigonometry is your strong suit, do the trigonometry. If you're doing this for your paid employment, yes, okay, absolutely, you probably want to find trigonometry so you can do it properly. But in that case, you probably have the AutoCAD drawing, you can just measure it off the AutoCAD drawing. But for the HSC, my attitude is you're always better off taking at least one guess using the scale drawing, just to have a rough idea what the answer should be before you do any geometry. Because otherwise, if you get an answer of, let's say if I get an answer of 300, I would know that was wrong. I know my answer has to be less than 500. Why? Because this triangle here is my right angle triangle, right? I've exaggerated it, but you get the idea, right? That's 500, this side here is 500, so this number here, if this is the hypotenuse, it has to be the biggest number. So this number here has to be some small amount, has to be between 400 and 500, something like that. Okay, so the thing is, what I need to know is I need to know what these angles are, right, in order to be able to find the equation. So to do that, what I'd have to do is I have to find out this whole angle, right? I'm going to call this angle here, I'm going to name that angle 2A, right, or 2 theta. Right? I'll call it theta because people like thetas. I'm going to call that whole angle 2 theta. And what I'm going to say is, well, this angle here is then going to be 1 theta. Right? Now, if I'm drawing this triangle, that, I know this is 1000. How big is this side of that triangle? What's this amount here? What's this amount? Sorry?
500?
No, this is 500. What's this amount?
250.
250. Okay. So, to find this angle, I need to use the arctan. Arctan theta equals 250 opposite over adjacent 1000. So the arctan of 1/4. I think I'll have my calculator there. So on most calculators, the arctan function will be written as tan to the minus something. Tan, okay, so just tan to the minus 1 of 1/4. Oh, 14 degrees. Yeah, close enough to 14 degrees. That'll do for me. So that means 2 theta is 28 degrees. Right? So now, I also have to find this size. Yeah, okay. To find this, do I see how I don't like the trigonometry? And do you see how I'm wasting precious minutes while I'm trying to figure out the trigonometry? I actually love trigonometry, but I worry about it in exam conditions, that I could be chasing a red herring when I could be getting these marks for free. Okay, so if I have this diagram here, that's my diagram. What I'm trying to find is I'm actually trying to find this triangle. I want to know that is 28 degrees, and this is 20 degrees, and this is 1030. So from that, I should be able to find this. So I know the hypotenuse, and I want to find the opposite. So what I know is sa, ka, toa. I want to find the opposite. I know the hypotenuse, so I'm going to say sine theta equals the opposite over hypotenuse. Now, I know the hypotenuse, so I'm going to move that over, and I'm going to say hypotenuse equal multiplied by sine theta equals opposite. If you struggle with that level of algebra, you need to let me know. Okay, 1030 sine 28 equals this value that we're going to call D. D equals 1030 sine 28 degrees equals 483.5. Now, I took a guess and I said it was somewhere between 400 and 500. Now, it's obviously much closer to 500, but that's okay. But I found the answer and it's within my estimate. Now, if you'd used a scale, I'm going to give that, if it's in my test, if I did this, gave you this question, if you used a scale drawing, I'm probably going to be okay with that, even if it's massively out. Right, 400 would have been too small, but yeah, if anything more than 450, I'm going to give that to you. That's within 10%. Okay, so now let's just do the question, right? So now that we've got our distances, we can now do the question. So you see the hard part was knowing that perpendicular distance, finding that perpendicular distance, right? We had to find this distance here. That was the hard part, what we called D. Yeah? Okay. So I'm going to say the sum of the moments about C equals 0. 0 equals, well, I've got P brackets 0 minus Q brackets 0, and then I have minus 10. Is this going clockwise or anti-clockwise? Da-da-da, da-da, da-da. Okay, anti-clockwise, and it's 1 meter away. I'm going to write in meters, not in millimeters. And then I have minus AB. Is AB going clockwise or anti-clockwise? We assume tension. Da-da-da. Okay, so anti-clockwise, and its distance was 0.484. And or here, assume anti-clockwise. I think my pen's starting to run out. Okay, so I'm going to, when we've talked before, if we have two negatives, we have to worry. So what we're going to say over here is we've got 0.484 AB. I've changed the sign because I've moved it over, equals minus 10. Okay, if I could buy half an AB, right, and half an Abby, right, I'm buying an Abby doll for $10. If half the Abby doll costs $10, how much is the whole Abby doll? Yep. AB equals 20.7. The answers are in kilonewtons, and it is in compression. Okay. You know, I really should be taking answers, taking photos for these. Okay. Next one. 2 to go. Okay. So this is the 2006 paper, and we've been asked to find the reactions at A and K, and then we're not going to bother with that if we don't have to, and then GI is what we're finding. This one here is what we're finding. GI Joe. Okay, so we're going to need to find a reaction, right? No getting out of that. Now what we can see is we have Ricky the roller and Penny the pin. We can see that there's no horizontal component, there's no forces that are pushing left or right. So it doesn't really matter which side's the roller and which side's the pin, it's the same. Right? What we can see is, oh god damn, it's not symmetrical, that's a shame. Okay, I want to find K. I want to find K because I know that I want to cut this side. So I'm going to need to find reaction at K in order to do that. If I can find the reaction at K, this is going to be a pretty easy question. So unfortunately I do have to find K before I can start. That's a shame, but often we can get away with it. So I'm going to say some of the moments about A, because I want to find K, so I have to eliminate A, equals 0. 0 equals not symmetrical, otherwise I'd be off to the races. Okay, I've got RA times 0, and then I've got minus 110 times 6. Is that going clockwise or anti-clockwise? That's regular clockwise, right? Yeah? Okay, then I've got same thing, clockwise 150 times 12, and then clockwise 120 times 18. Yeah, 18 is 180. And then I have minus RK, and RK is 24 away. Okay, I can just move that straight over, because it's minus, I can change the sign, and I can say 24 RKs equal, and then I just add these ones up. I don't know why I'm in blue, I shouldn't really be in blue, but... Okay. 110 times 6, I should have been out doing my head. 610, 150 times 12 equals, and then 112 times 18, 2160. Okay, add all that up. Okay, equals 4620. So RK equals 4620 divided by 24 equals 192.5 kilonewtons up. Now, if you got that wrong, if I've got that wrong, and we just keep on working, that's okay. They will not take marks off because of what they call carried errors. I also want to say that 2020 was supposedly the last year that you could still get full marks without showing working out. And it's really imperative that I say that in the professional life, you are not allowed to not show your working out. If you do, right, your boss, right, she has to check it, and then her boss has to check it, and then you have to go send it to an independent verifier, and they have to check it, right? There's 3 different people as a junior engineer who are going to check your work, right? And if they can't understand what you've done, where your workings come from, they're going to just ask you to do it again, right? Not acceptable to not show working out, professionally or academically. And the worst of all possible situations, and for young aspiring engineers, it's worth saying this, those 3 people are not the people who are going to yell at you for not showing you working out. Let's say that you happen to work in your own single independent firm and you don't have those people who are checking your work. The person who's going to ask you where to show you working out is going to be the coroner when someone dies because your bridge has collapsed, right? And in that situation, you want to have notes. You have to keep your notes for 7 years minimum, right? Engineering firms probably have to keep their notes professionally for a lot longer. I don't know, I was in that side of the record keeping, right? For bridges for hundreds of years, so that you need to show your notes, right? Is the key here. Okay, so now that we're off that point, we are trying to find GI. Okay, trying to find GI. We've also got HI and HK. Now, we're finding GI, which means we need to eliminate HI and HK. How do we eliminate them? What method? Meetup. Oh god, we've just got so many meetups. If I'd been smarter, that would have been a great place. So where do they meet up? What location? H. Yeah. Okay. So what we need to know then is what is the distance from H to K? What is this distance from H to K is 6 meters? And then, what is the distance from GI to H?
3.
3. Oh, they gave that to us. That's nice. Okay. This is pretty easy 2 marks for this part. Okay, so in this case, what we're going to do is we're going to say sum of the moments about H equals 0. 0 equals HI brackets 0 minus HK brackets 0. Again, you can see why other people just ignore those lines, right? But I like to include them. I like to say that's why we're doing things. We've got GI. GI is 3 meters away. Is it going clockwise or anti-clockwise around H? GI is pulling out. We're assuming, so we've assumed tension, therefore anti-clockwise, yeah, in this case. And then we've got minus 192.5 bracket 6. Again, is this going clockwise or anti-clockwise? Anti-clockwise. And again, we've said it before, we'll say it again, if you can see that there's only 2 forces and they're both negative, you're going to have compression city. Okay, so I'm going to bring this over here and say 3 GI equals times 6 equals 115. So if I can buy 3 GIs for $1,000 for $1,200, how much is each one going to cost?
About 400.
About 400. Sounds exactly what I would have guessed. And a GI is, in fact, 385 newtons. Is it newtons or kilonewtons? Kilonewtons. And in compression. I didn't write here. Oh, I should have written minus and said here negative. Therefore, assumption was no good. Therefore, compression. Okay. We'll take a photo of that. Should have been taking photos. I regret that now. Okay. Last one, 2010. Unless I've already done it in another recording, in which case, I don't think I have. Okay, they have asked us, can you scroll down a little bit?
Yeah.
I think they asked us to find BJ. Yeah, a little bit down. Next page. Yeah, okay, scroll back up. And then just click on this page so I get a bit more working room. And I guess you can make this one a little bit bigger. Yeah, again. And then click there. Okay, so thank you, that was great. What we want to find is BJ. This guy here, like BJ Novak from The Office. Okay, so what I'm going to do is I'm going to put my section line. Now there's a real skill, unfortunately in this case, that it hasn't been that difficult to figure out where to put your section lines, but knowing where to put your section lines is a real skill. And in this case, they just happen to have been easy. Now the question is, do we want to take the top half or the bottom half?
Top.
Top half, because then we don't have to find these stinking reactions, right? We hate those reactions. Every time I have to do them, I'm angry. Okay. So what my diagram is going to look like this, sort of. Now, I have to show all external forces and all cut members. Okay, so I have BJ, and I have IJ, and I have AB. And all 3 of these I'm drawing as pulling out of the node, because when we tell the minions to pull, right? When we're anyway. Okay, so we've got 3 forces there, and we're going to assume each of them is in tension. Yep. Okay, we want to find BJ. BJ is a target, and then we have these 2 distractors. So how are we going to get rid of our distractors?
Meet up at J.
Good guess, meet up at J. BJ and IJ both meet up at J, but AB and IJ, do they look like they're parallel?
Oh, yes.
Yes, they're parallel, right? So if they're parallel, they're never going to meet. So if they're never going to meet, what method do we use? Lone wolf, great. Okay, so what we know is that BJ, what can BJ do that the others can't? It can take horizontal, right? So we can, first of all, what I want to show my boss is that I know that there's horizontal components. So I'm just going to write sum of the forces horizontally equal to 0. Okay, what are the horizontal forces I have? BJ and 15. So what I'm going to write is 0 equals, now I have said